Hey kiddos, here we are at lesson 7 in module 3, and this is the last lesson before the mid-module assessment. So I know it has come really fast, and holy moly, only 1 through 7 lessons and then a big test. So that's just the way it goes in this module. Everybody seems to be enjoying the fractions. They're not too hard. It makes sense, and then we'll round out with the rest of the module. I think there are, well, like 20 something lessons in here. So anyway, oh no, it looks like there are only 16 lessons in module 3. So this will go pretty quickly. But it's word problems. And it's so sad that everybody isn't here because I love for you guys to collaborate on these word problems. Just read it, talk about it, draw. Sharing the ideas is really what makes things easier. I know sometimes when I would do problems when I was a kid, I would just get so in my head and I'd be all stuck, like I don't know where to start, but talking about it can really help you make sense of these problems. So I'll start reading, and of course we're going to solve them using the read, draw, write strategy, and you can use a variety of tools. Tape diagrams work, area models work. We can also just use the mathematical model and figure it out by finding common denominators. So let's get started. George weeded 1/5 of the garden, and Summer weeded some, too. When they were finished, 2/3 of the garden still needed to be weeded. What fraction of the garden did Summer weed? Well, let's draw the garden. And the garden looks an awful lot like a tape diagram. Okay, so let's just put this together. We know that George weeded some of the garden, and this is going to turn out to be 1/5. Summer did some too, but I don't know how much that is. When they're finished, 2/3 of the garden still needed to be weeded. So let's just pretend that that is 2/3, and that's an appropriate size. So what fraction of the garden did Summer weed? So this is the whole garden. And right now I don't have a fraction for that because I have different denominators, and I need to put these together so I can figure out how much the whole is. So first of all, let's add what we do have. 1/5 and 2/3. And I want to combine these, but I don't have common denominators. So because we're not limited by our area models, which you can certainly make an area model here if you want, I want to see if you guys can solve this with just the math, okay? Now, you know that you can multiply these two and get common denominators. So let's set this up. If I was going to multiply these two and get 15ths for both, 5 times 3 is 15, but I also must change this top number at the same scale. So I'm going to use the scale factor from a couple lessons ago. And I'm going to do this here, and I'm going to move it right there. So I know that I multiplied 5 times 3. Therefore, I have to use 3/3. Therefore, 3 times 1 is 3. So my equivalent fraction for 1/5 is going to be 3/15. And in the same way, I'm going to take my 2/3 and I multiply the 3 by 5. So squish this over here. This is going to be times 5/5. This fraction here, 3 times 5 is 15, so 2 times 5 is 10. And so this gives us our new fraction. So now I did this without making a fraction model, but I essentially did what the fraction model forces us to do, which is to lay the 3 parts over the 5 and lay the 5 parts over the 3. But I'm doing it by using the scale factor. So we're kind of combining all of our skills from the last few lessons in what I think is the least busy or the easiest way. Now I've got 15ths, and I can add 3 plus 10 and get 13/15. And so what is that the answer to? That's how much was left. Still, it's still weedy. It's still weedy, okay? And that's what's still weedy and what George already did. So what I need to find out is what Summer weeded. And so if I see that this is already done, okay, this is done. So what's left? Well, look at what I could use for the whole. If I have 13/15 that is done by George or unfinished, what is this? This means the whole. This means the total number of parts. The total number of parts or pieces. And so this is the whole. If this is the part that is done or unfinished and this is the whole, then the whole is 15/15, and that would be all the garden. So you take your 15/15, subtract what is accounted for, and then you end up with 2/15, which is Summer's portion. Make sense? There you go. Okay, and so we did that all without using a tape diagram. And so I hope you find that handy. I really love using the scale factor. I just think it makes everything really straightforward. Okay, so let's move to the next one. Jing spent 1/3 of her money on a pack of pens, half of her money on a pack of markers, and 1/8 of her money on a pack of pencils. What fraction is left? So we have, again, let's break this into parts. Let's talk about this being all the money. Always at the top, label the whole, okay? Even if you don't know what it is. So we've got pens, we've got markers, we've got pencils, and we've got money left over. Okay, now it doesn't matter that the fraction sizes are not exactly, like this says 1/3, this says 1/2, this says 1/8, and this is unknown. I don't really care. All I need to know, all you need to know is that there are 4 parts. Okay, we're not making an artistic representation of these fraction pieces. We're showing that there are 4 parts to the whole, and that's what's important here. Now let's assign our fractions. Pens are 1/3, markers are 1/2, pencils are 1/8, and this is unknown. A tape diagram is designed to show you that there are several parts that make up the whole. So I can put these together, and all of a sudden I see that I need to combine these, and then I would take that away from the total in order to figure out what's left. Now, here we have 3 fractions. So our strategy of skip counting to find this common denominator, I would always start with the biggest number. I mean, I could go 2, 4, 6, 8, 10, but again, it's going to be more helpful for me to start with the big number because I will have to count less. So 8 times 2 is 16. 8 times 3, and I'm looking for matches. Now I know I will get to 16 with 2 because this is an even number, but will I get to 16 with 3? 6, 9, 12, 15. Nope, I will not get to 16 because if I'm only 1 away, the next one would be 18. So after 16, the next one is 24. Will I get 24 with 2? Yes, I will. Will I get to 24 with 3? Yes, I will. Okay, so if you think about the multiples of these numbers, you can find the lowest common denominator without having to multiply all of these together to find a common one. You can find the lowest one right away. So line them up, skip count, find a common denominator. Now I have a common denominator. So let's change these all to 24ths. Okay, what are you doing, Mrs. Ednes? There's no area model there. That's okay. I'm going to use a scale factor. So 3 times what? will give me 24. Okay, you can do this. You can count all the way out here, and you will find that there are 8. 3 times 8 is 24. So 2, 3, 4, 5, 6. I just was missing the 21 when I did the dot, dot, dot. 7, 8. Okay, so that's going to be how many times you have to count to get your number out here. And so this is going to end up looking like 3 times 8 is 24. 8 times 1 is 8. So 1/3 is equivalent to 8/24. How do you get from 2 to 24? That's a lot more counting, but you should know that it's times 12/12. So your scale factor here, 2 times 12 is 24, so 1 times 12 is 12. How do you get from 8 to 24? Well, times 1, times 2, times 3. Scale factor here is 3. 8 times 3 is 24, therefore 1 times 3 is 3. So I've changed my fractions, but at the same ratio. So 8 is still 1 out of 3/8 to get to 24. 12 is 1 part out of 2, and 3 is 1 part out of 8 to get to 24. Okay, so now I have common denominators, and I can add all the way across. So 12 plus 8 is 20, and 20 plus 3 is 23. So all of these fractions together for the pens, markers, and pencils represent 23/24 of Jing's money. But there's another question: what fraction of her money is left? And so again, in the same way that I was looking for that fraction at the top, the whole is going to be everything out of everything. If this is all the parts, then the whole is going to be the same number on the top. So 24/24 is the whole, and if you want to know what's left, do 24/24 minus what you had, but you don't have to actually write this because you probably know that you can count on 1 time and get 24/24. So 1/24 of her money is left. Ta-da! There you go. So that's number 2. And number 3, Shelby bought a 2-ounce tube of blue paint. She used 2/3 ounce to paint the water, 3/5 ounce to paint the sky, and some to paint a flag. Oh, this is a hard one. I remember this one. After that, she has 2/15 ounce left. That's of 1. How much paint did Shelby use to paint her flag? So this one, I like to have 2 separate tape diagrams, and I'll show you why. Okay, so the first tape diagram, this is the 2-ounce tube of paint. Okay, and it's blue. Not that that matters. I think we're just using blue the whole time. Okay, she used, then it starts giving you amounts. It's 2/3 of 1 ounce for the water. And so we've got another 1 ounce, 3/5 of 1 ounce to paint the sky, and then some to paint the flag. And then she has some left. So in this 2-ounce tube, we have some things that are used: water, sky, flag, and left. Okay, and I can assign amounts, but what I would like to do is also create a tape diagram for 1 ounce at a time, because the numbers that they're giving me are in single ounce amounts. Single ounce amounts, different end letters, but same sound. Sorry, I'm taking a linguistics class right now, noticing all the strange things about language. Okay, so water is going to be 2/3, and then sky is 3/5, and some to paint the flag, and then she has 2/15 ounce left. So in order for us to figure out how much the flag is, first I have to figure out how much is used. So let's look at our denominators. And we have 3 and 5 and 15. Well, that is so convenient of them. Because 3 and 5 and 15 all have 15 in common. And if you're not sure about that, remember, line them up over here. Skip count. This is going to be your times 1. And then what's times 2? 6, 10, 30. I don't even need to get here because hopefully you would know that 5 times 3 is 15. And then ... 3 times 5 is 15. So they all have 15 in common. That's why I just put this straight away down here. So, again, the scale factor. And after you get really good at this, you don't have to write it anymore. But 3 times what is 15? That's going to be 5/5. And 3 times 5 is 15. That's where I got that. And 2 times 5 is 10. That's where I'm getting the 10. So this is equivalent. 5 times what is 15? Well, 5 times 3 is 15. So if I multiply by 3 on the bottom, I will multiply by 3 on the top. And 3 times 3 is 9. And now I have an equivalent fraction for 3/5. Now this one, I don't have to change because it's already 2/15. So this is equivalent now to these. So this is how many ounces are used with those items that I already know about. 10 plus 9 is 19, 20, 21. 21/15. Now what's happening here is that each ounce is in 15 parts. So break it up. Okay, I'm going to do 5, 10, 15. So I'm breaking this one up in 5, 10, 15. 5 pieces. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the same thing here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if you have they're not all exactly the same, it's okay. Just make sure you only have 15 parts. So each 1 ounce has 15 parts. So let's see the water, the sky, and what's left. And we'll label them on our model. Okay, so if I have 10/15 for the water, that would be 1, 2, 3, 4, 5. Now I can't even tell where my original lines were. 6, 7, 8, 9, 10. So this is water. And sky is 9/15. 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice that I'm doing them a little bit differently. Sky, that's 9. And then I have 2/15 that are left, so I can just group that right here. Left. And then this is literally showing you what the fractional units are that are left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I have used 21 and I had 30/15 to begin with, because that's all of the 15ths, 15/15 here and 15/15 here to make 30/15, you can see, there go the lights, you can see that, that if you subtract that, you'll mathematically get what's left, and 9/15 is left, or you can count. And when I say left, I don't mean this part left, but I mean what's left over in your tape diagram. Okay, and that's what's for the flag. On the flag. Okay, so hopefully that is okay, clear. I know that one's a really hard one. It always takes everybody a bit of time. So there you go, and then we'll move on. Jim sold 3/4 gallon of lemonade. Dwight, Jim and Dwight, aw. Okay, Dwight sold some lemonade too. Together they sold 1 5/12 gallons. Who sold more, Jim or Dwight? How much more? And surely they will have a fancy competition about this. Together they sold an amount, and now we know the whole, WHOLE, is 1 5/12 gallons. And I know that I have Jim's amount and Dwight's amount, and Jim sold 3/4, and some that is unknown here. Okay, and so how do I find this out? Well, this time I don't have all the parts, and I do have the total. So I need to take the total and take away the part that I know in order to find the part that I don't know. So when you have this and they don't have a common denominator, you have to make this one match this one. Now I don't want to multiply 12 times 4 and have 48 pieces in my area model. That would be, it makes me tired just thinking about it. Okay? Also, if I made an area model, it would be 12/12 and 5/12. Okay, so this is a total. So how many 12ths do I really have in this mixed number? Okay, 12 plus 5, 17/12. So I have 17/12. I just need to have 12ths here. So what scale factor do I need? What scale factor do I need to get 12ths out of 4ths? Well, 4 times 3 is 12. And what you do to the bottom, you do to the top. So your scale factor will always work with both numbers. So 3 times 3 is 9. Now I have minus 9/12. So 17 minus 9 equals 8. And that leaves me with 8/12 for Dwight. This is not in simplest form, though. And so if you want this to be in simplest form, you can divide by 4, because 4 is a factor that goes into both numbers. So 8 divided by 4 is 2, and 12 divided by 4 is 3. And so Dwight's amount is 2/3 of a gallon. Now, let's see. The next part of the question. Who sold more lemonade, Jim or Dwight? So, couple things here. This is where I really love to, I love to change everything into decimals, because it just helps me see like exactly how much we have. And remember that every fraction is a division problem, and so you can divide. You can look at these, and I mean, if you look at quarters, money, 3/4 is like 75 cents. So 2/3 is less. So Jim sold more. But we have a couple different ways we can do this. Let me get one more thing. I don't want to do all the decimal division if I don't have to yet. So let's see. How about we'll do the 9/12, and then 3/4 gallon, and that's gonna be not this one, 3/4, and we'll turn this into 12ths. Sorry, I like lost track where I was. And times 3. Well, that's that one. Sorry, I'm like taking a moment here. And then 2/3, 2/3, 2/3. 2/3 equals 70/12. And why don't I have that one? Okay, that's where it is. Sorry, I'm like trying to find my way. And so that's where you've got your times 4, and you get your 8. And so Dwight is 8/12. I'm like, where are my numbers? 9/12 minus 8/12. There it is. 1/12. So the janitor comes in. I'm like, I always want to talk to her and ask her how her day is. I'm like waving at her, but so I'm so sorry for the interruption. Anyway, I know we're getting up to 24 minutes and we're almost done. But 1/12 is what the difference is between who sold more. And Jim sold more, but he only sold 1/12 gallon more. All right. And that's the final answer there. Okay. So last one, Leonard spent 1/4 of his money on a sandwich. He spent 2 times as much on a gift for his brother as on some comic books. He had 3/8 of his money left. What fraction of his money did he spend on the comic books? All right, so again, we have lots of money and expenditures on supplies. Let's make a tape diagram and show all the different parts. Okay, sandwich. And 2 times as much on a gift for his brother as on some comics books. So we have a gift, and we have comics, and then he has money left. So we have some different sections here, but this one is going to eventually be 2 times as much. Okay, and so let's start putting the fractions with it. The sandwich is 1/4. The gift is 2 times the comics. He has 3/8 left. So we have to figure out the portion size. So let's make a different tape diagram now that we have our pieces. And we'll do, let's make a common denominator, because I can't really use 4ths and 8ths. So I want to make this into 8ths. So what can I multiply by? 2 is the scale factor. Excuse me. And that means 2/8 will be the amount on the sandwich, and 3/8 are what are left. If everything is in 8ths, then why don't I just divide this whole thing into 8ths? And now I can label everything pretty clearly. Sandwich is 2/8. How much left? 3/8. And now the relationship or the ratio between the gift and the comic books is that the gift is twice the comic books. So I can use a different color and say gift, and comics. And that makes up the full 8/8. Okay, so what fraction did he spend on the comic books? Well, he spent 1/8. On comic books. Okay, and there it is, and you can just see that one. So I hope that was helpful, and I hope it didn't take too long. Poor Jim and Dwight. Anyway, have a great day. If it's helpful, click subscribe. If not, try another video another day. Have a super day.